Hello, everybody. Continuing with my solving of the sample papers, which I started a day back, we had discussed question 1 and 2. Today, we discuss question 3. The degree and order, respectively, of the differential equation x squared d square y by dx square equal to x dy by dx minus y whole cube. Now, what is the order and degree? So, if I expand this, I have x cube dy by dx whole cube minus y cube, and then I have minus 3x dy by dx within bracket x dy by dx minus y. Basically, a minus b whole cube formula. Now, in spite of that also, you can see the order of the differential equation will remain 2, because the highest differentiation that is happening here or derivative that is present here is d square y by dx square. And then degree means we look into the power of it, which is 1. So hence the degree and order is 1 comma 2 for this question. Moving on, question number 4. The area of the region bounded by the ellipse x square by 25 plus y square by 16 equal to 1. Now here, if you go by the longer method, it will take more time, and 1 minute, 1 mark question should not be given more than 1 minute, or in fact less than that. So since this, if we can remember that the area is pi AB, so then 25 means your 5 square and 16 means 4 square. So pi AB is 20 pi. So that will save on your time. Now question number 5, if 0 to 1, 3x square plus 2x plus k dx equal to 0, then find the value of k. So for this, you will integrate. This is direct integration, and then you will equate it and find out the value of k. That is which is shown in the following calculation. Yes. Now coming to question number 6. Let me clear my drawings. We are seeing value of minus 1 to 1, x minus this. What is this? Please identify this as the greatest integer function. Now, greatest integer function needs a redefined approach, which is y equal to minus 1 to 1. The x minus x. Now, you see minus 1 to 1 x dx will separate it out. And minus 1 to 1, you need to again check out that what is the value of the greatest integer function in that case. Okay. So, we have your minus, we can, if we look at the function, we have minus 1, we have 0, we have 1. Now, when it is 0 to 1, the greatest integer function falls on 0. And when it is minus 1 to 0, it falls on minus 1. So, accordingly, we'll use that, and minus 1 to 0 dx will be minus 1, and obviously 0 to 1 dx becomes 0. So, using that, we find out the answer to be 1. If the following table represents a probability distribution of the random variable x, x bx 1.1, 2 gives 2k, and so on. So what is the value of k? So we will be doing all the application as probability of p of x is 1. Because sum of the probabilities is always 1. And then you will put the value. Just p of 1 is 0.1. P of 2 is 2k, P of 3 is k, P of 4 is 0.2, P of 5 is 3k, and P of 6 is 0.1. And then after solving, you get k as 0.1. Then question 8, value 0 to 2 pi dx e sine x plus 1. So here we will be using f of a minus x so that we can simplify it. So see here, the value of 0 to 2 pi dx e sine x plus 1. So if I put sine 2 pi minus x, we get minus sine x. So finally, we get 0 to 2 pi e to the power sine x dx by e to the power sine x plus 1. So adding 1 and 2, we are getting 2i equal to 2 pi, 1 dx equal to 2 pi. So I is equal to pi. So this is basically using the properties of definite integral. Now, vector equation of the line joining the points 3, -2, -5 and 3, -2, 6. So the 2 points are given to us. So we will be using R bar equal to A bar plus lambda B minus A bar. So using that, you will get the equation, match it up with the options, and then mark the answer. Oh, then moving on, the angle between the lines having direction ratios 1, 1, 2 and √3 -1 and -√3 -1, 4 is. So what angle between two lines having, we know the formula, cos theta equal to modulus cos theta is equal to A bar dot B bar divided by modulus A modulus B bar. So using that, we will be calculating the area, correct? Sorry, the angle between the two lines. So we will continue from question number 11 in my next video. Stay tuned.